Good afternoon, all of you. Now, the remaining questions we can discuss today. That is from question number 8 onwards. Page number 214, question number 8. All of you read the question. A factory requires 42 machines to produce a given number of articles in 63 days. Okay, 42 machines are used. Okay, 42 machines are used to make a number of articles to produce a given number of articles in 63 days. Okay, now what we want to find out, how many machines would be required to produce the same number of articles in 54 days. How many machines? We don't know the machines. In how many machines would be required to produce the same number of articles in 54 days. So when we think about this question, here the number of articles produced should be the same, but here number of machines are different given. If 42 machines are used, how many days are required? 63 days are required. Then how many machines should be there to complete that producing that articles in 54 days. So we can think about, if the number of machines increase, number of days will be decreasing. Okay, just like if the number of machines is decreasing, or if the number of machines is slow, then we need more days to finish that work. So it is an inverse variation. So how we can use that for inverse variation? So as it is an inverse variation, we know 42 into 63, x1 y1 equal to x2 y2. So 42 into 63 is equal to, then x into, we don't know the number of machines in the second case, x into how many days are there? 54 days. From this you can find out the value of x. Okay, all of you find out its answer. From this it is very easy. X is equal to 42 into 63 divided by 54. I will just give the clues, all works you want to do along. Next question, look. A car takes 2 hours to reach a destination by traveling at the speed of 60 km per hour. Okay, a car takes 2 hours. Okay, it take 2 hours to reach the destination by traveling the speed of 60 km per hour. So the speed is what? 60 km per hour in the first case. And how long will it take when the car travels at the speed of 80 km per hour? If the speed is changed as 80 km per hour, how many times are needed? That is how long it will take. So if the speed is 60 km, how much hours is needed? How many hours needed? 2 hours are needed. Now we know, if the speed increase, if the speed of the car increase, we will take only some time. Okay, it will be decreasing in the time. If the speed increase, the time will be decreasing. Just like if the speed is decreasing, then we need more time. So it is an inverse variation. So we can use the same way, x1 y1 is equal to x2 y2, that is 2 into 60 is equal to, instead of here we can take x into 80. Okay, from that we can find out the value of x. Very easy. Next question. 2 persons could fit a new windows in a house in 3 days. Okay, so you want to understand which variation from the question itself. In the first part we already discussed the direct variation. So in this full R, from it is inverse variation. So it want to be very clearly, you want to understand the given question is direct or inverse. Next question, 2 persons could fit new windows in a house in 3 days. 2 persons need, how many days need? 3 days need for fitting 2 windows. So first question, here I have 2 questions. First one is, one of the persons fell ill before the work started. How long would the job take now? So one of the person fell ill means if the number of person will be 1, if the number of person, if it is 1, how many days are needed? We don't know the number of days, so we take it as x days. So if the number of person decreasing, then we need more days for completing that work. So it is an inverse variation. So 2 into 3 is equal to, here if the number of person is given 1, so 1 into days we don't know, so that we take it as x. So what will be x? X is equal to 2 into 3 6, 6 by 1, that means 6 days are needed. Okay, next question. How many, in the same second question, sub question, how many person would be needed to fit the windows in one day? How many persons are needed? Okay, how many persons would be needed to fit the windows in one day? So instead of 2 persons need 3 days. Okay, so here the question is how many persons are needed. So we don't know that number of persons. Let x persons are needed for finishing the work in one day. So here x1 y1 is equal to x2 y2. So what we can say, x1 y1, 2 into 3 is equal to x into 1. So in this case also x is equal to 6. That is 6 persons are needed for finishing that work. Just like last question, a school has 8 periods a day, each of 45 minutes duration. Okay, if the each period have 45 minutes duration, if it is 45 minutes duration, how many periods are there? 8 periods are there. Okay, 8 periods a day, each of 45 minutes duration. How long would each period be? If the school has 9 periods a day, okay, assuming the number of school hours to be the same. So here we don't know the time. How many time will be need if the number of periods have 9 periods. Anyway, here the starting time and finishing time of that school time is same. Okay, if the school started from 8 o'clock to 4 or 10 o'clock to 4, in the two cases it is the same time, starting time and finishing time. But if the duration of the each period, if it is 45 minutes, they will get how many periods? 8 periods. And the question is, what will be the how long it will take for each period if 9 periods are there? So you can think the minutes, how the time will be decreasing or increasing. If the periods increasing, if the number of periods increasing, the duration will be increasing or decreasing. All of you can think it will be decreasing. If the number of periods increasing, the time duration will be decreasing. So it is an inverse variation. So x1 y1 45 into 8 is equal to x2 y2. x2 we don't know, so that we can take the variable x into 9. From this you can calculate x. Okay, so x will be 45 into 8 divided by 9. Okay, so it will be 5. So 40 minutes are there for each period. Only 40 minutes is available because if they need 9 periods. So that chapter is completing. So next we want to start the next chapter, factorization. Okay, factorization we want to start. So anyway, all of you just read the first part of this factorization before the next class. Okay, thank you.